Welcome to this week's STEM Challenge at the Red Bank Public Library. This week we're going to be talking about floating and sinking and encouraging you to design a device that will help something float in a body of water. The first video we're going to watch is from SciShow Kids, which we watched a few weeks ago, talking about the concept of sinking and floating and of density and how to change that around to make something be able to float that was previously only able to sink. We're going to talk about buoyancy. So let's watch this video and learn. Thanks for joining us.
To the bottom, while other things float on the top. Why does that happen? Well, I brought some friends to see if we can figure that out.
Hi, everyone. My name's Webb,
And hi, I'm his sister Bill. Since we live in a pond, we see a lot of things sink.
and a lot of things float.
I bet. You can actually learn a lot about something by seeing what it does in the water. So I'd say this calls for an experiment. First, we'll need a pretty big container of water. We'll fill it about 3/4 full and set it up where it's okay if some splashes out. Now we need some stuff to put in the water.
All kinds of different stuff.
We're going to look for a couple things around the fort that are okay to get wet. If you want to try this experiment at home, make sure you ask before you put anything from your house into the water. Let's see what we found. All right, Squeaks found a penny. I found a stick. And Bill and Webb, they found 2 different spoons, a metal one and a plastic one. Good job, guys. Now, before we get started, let's take a closer look at what we'll be testing. All of these things are made out of different materials, like metal, plastic, and wood. Some of them are pretty small, and some are a little bit bigger. I think we have a pretty good group of objects because they're all pretty different. Now, before we start putting things in the water, let's guess whether each one will sink or float. And let's keep track of our guesses. But how will we... Great idea, Squeaks. We'll use a chart. All right, let's start with the stick. Bill, Webb, what do you think? Will it sink or float? Well, I can tell you guys are pretty excited. Tell us what you're thinking.
Well, in the pond where we live, I've never seen sticks that have sunk. Only ones that float.
Well, that's because you haven't seen the ones that have sunk.
Well, that's because they all float, Webb.
Okay, fine. Put me and Bill down for the stick floats.
Okay, here we go. And it floats. Good job, you two.
Yay!
Next, let's try the metal spoon. What do you think? Will it sink or float?
Well, I've never seen a spoon float.
Me neither.
Quack.
Quack, quack, quack. We think it'll sink.
Okay, let's see. It sinks.
Yeah, we're the smartest ducks in the world.
Yeah. Now, what about the plastic spoon? Do you think it will sink or float?
Quack, 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 quack,
Quack, quack.
quack, quack. Well, it's the same shape as the other spoon.
Yeah, and we think it might sink, just like the metal spoon did.
Okay, let's see. It floats.
Oh.
Bummer.
Well, that's okay, guys. That's how we learn, right?
Yeah, I guess. It's just weird. The other spoon sank.
Well, let's record our results and see if we can find out why it sank after we test our next object. Our next object will be the penny. Do you think it will sink or float?
Well, a penny feels a lot like a metal spoon, so I think it'll sink.
All right. And Webb, what do you think?
Well, it's so light, but kind of small, and I don't usually see things that small floating. I'll have to agree with my sister this time. It's gonna sink.
It sinks!
Oh.
Now that we've tested all of our objects, let's look at our chart. Some of the objects floated, and some of them sank. Let's see. The metal spoon and the penny sank. The plastic spoon and the stick floated. Is there anything that's the same about the things that floated and the things that sank?
Well, we know that the metal thing sank, and the metal spoon feels kind of heavy.
But so does the stick, and the stick floated while the spoon sank, so maybe it's not all about how much something weighs or its shape?
You're right, and that might help us explain why some things float and some things sink. The answer has to do with something called density. Everything, and I mean everything, is made of tiny particles that we can't see. And how dense an object is depends on how much space is between those particles.
Particles?
Jesse, what the quack is a particle?
Now that's an awesome question. Let's dense, like the metal spoon. But if those marbles were spaced really far apart, that'd be more like what the particles are like in something that's less dense, like the plastic spoon. The metal spoon is more dense than the plastic spoon. It's about the same size and shape, but the particles that make it up are closer together than the particles that make up the plastic one. But remember, everything has density, including water.
What?
It's true. Since water has its own density, if something is more dense than the water it's in, it'll sink. The metal spoon and the penny were more dense than the water, so they sank. And the stick and the plastic spoon were less dense than the water, so they floated. So will it sink or will it float? It depends, in part, on density. How did your experiment go?
Did you make some wrong guesses like us?
I bet you got some right.
Let us know what you use in your experiment and how it turns out. Just get help from a grown-up and leave us a note in the comments below. Or send us a picture at kids@thescishow.com. And we'll see you next time.
Bye.
Bye.
Well, looks like that was one way of learning about density of objects. We have some more videos to show you from a science museum. And the science museum, hold on one second, looks like it might be ready to go. Here we go. So, we are going to go ahead and watch Make a Floating Device. Have you been spending a little more time in the bath lately? We want you to design, build, and test your own floating device using creativity, problem solving, and a few things from around the house. This is your challenge.
Have you been spending a little bit more time in the bath lately? It's a great place to relax and unwind, to splash about, but also to do some science. We want you to design, build, and then test your own floating device using your creativity and problem solving, and a few things you can pick up around the house. The first thing you'll need is a space where it's okay for things to get a little bit wet. Bathroom or out in your garden are good spots. You're going to need a sink or a tub or a bowl. You and your adults need to locate a few different kinds of objects from around your place. I have things like dinosaur toys, cutlery, blocks, plasticine, marbles, that kind of thing. Once you've got all those things together, I want you to start testing. Take those objects and pop them into your water. Let's find out what floats and what sinks. Does the size, weight, and shape make a difference? Can you change the shape of any of your objects? And does that affect how they float or sink? Once you've tested those things, it's time for the challenge. I want you to take a piece of aluminium foil, approximately 30 centimeters by 30 centimeters. And I want you to shape it into your own floating device. You and your family can have a bit more of a look around and see if there's anything you have that could help your contraption to float even better and to decorate it as well. Place on the top of your water and see how many teaspoons you can get floating on top. Let us know how many you manage. When you're all done, please take some photos or videos and share them with us.
Okay, so that was a simple challenge, and that's all we're really going to need this week is a good piece of aluminum foil and some objects from around your house. If you want to venture into testing other objects other than aluminum foil, I've made rafts flew out of popsicle sticks and duct tape, out of taped together drinking straws, and you might find some new kind of suggestion that you can post in our comments or on our Facebook page. If you're really looking to get your parents or older brothers and sisters, friends or cousins involved in the challenge, go to this site, discovery.org, and there are 6 pages of directions for designing a flotation device, but a little bit trickier because the weight you're going to be using of the object is not just pennies, is not just metal spoons, but it's a can of soup that you might have lying around your house. And you have to design a flotation device that is going to hold your can of soup up above the water rather than causing it to sink down to the bottom. So let's just review this very quickly. And even though it says grades 3 to 5, grades 6 to 8, I think with some ingenuity and some help and a little guidance, even some younger kids might be able to do this. I have to say, I have not yet been successful in my attempt to float the can of soup, but I'm going to continue, and maybe I will post my video to Facebook later this week if I figure out how to do it. Maybe I'll get some hints from you guys that'll help me along the way. So your design challenge is using the materials provided, design and build a flotation device that can keep an unopened, make sure it's unopened so it doesn't spill, can of soup afloat in a bucket of water for a period of time of 1 minute. So it doesn't have to stay floating forever, but as long as it stays above the water for 60 seconds, which is equal to 1 minute, of course. And your materials you need is a basin or bucket, can of soup, towels, and water. And then consumables. These are optional. You don't have to use them all, but you can use one or more of them. Drinking straws, balloons, plastic sandwich bags, non-zip, foam pieces, many pieces of various shapes and sizes. So foam, sponges, anything like that. Corks, interesting. Those might be harder to find, but corks work great. Glue and rubber bands. Now fill a basin with enough water that a soup can will sink to the bottom. Arrange materials neatly so that you can see the options available to you, and make sure your soup can actually sinks in advance. So you want to make sure that by some miracle it doesn't actually float, that it follows the rules of most other soup cans, and because of its density, its particles being close together, it actually sinks to the bottom. You notice this says dream big, and this is exactly how we're doing our engineering design process of dreaming big. So it's telling you a little introduction. A personal flotation device, like a life vest or jacket, is designed to keep a person afloat with their chin above water in the event of an emergency. And it asks you some questions about that you can discuss with friends and family. And you can see at the bottom it says actually life jackets made of cork were available in the early 19th century. Inflatable life vests were invented not until 1928. So your design challenge. It says, note that you can choose to limit use of materials to fit your time or space constraints, but otherwise use any of the materials provided. The goal is to keep the can afloat for 1 minute. Design the flotation device to be removable. I'm going to opt for that. I'm not going to make that a requirement for our design, but in this particular challenge, when they first devised it, they made that a requirement. And remember, use balloons, foam pieces, or corks to design your flotation device to keep the can afloat. It doesn't have to be an inflatable device. It can be a device that's already in a passive state, that's already ready to go. Ask lots of questions while you're building and keep track of what works or doesn't work, and see how you did by testing it. There's some variations of the activity that you can do. And then remember, here's some definitions. We talked about buoyancy in the beginning of this session. That is an object's ability to float in water or other fluid. If you're working with younger children, here are some questions that you may want to incorporate into real-life experiments and real-life experiences. And your engineering connections and science connections that I'll let you read about and find out about. So Dream Big is done in connection with the Carnegie Science Center, and thank you to discoveре.org for posting this challenge for us. Good luck. Let me see your aluminum foil floatable device, or boat if you want to call it. And if you want to get a really big challenge, go ahead and try the can of soup. We'll be looking for your postings, and this week's code word is float.